Hi, this is the alcohols and carboxylic acid mind map. So first learning objective is to describe the alcohol's homologous series containing the OH functional group and name and draw the structures of the first four alcohols. So you are only expected to know methanol, ethanol, propanol as well as butanol. Beyond that, you are not expected to know. So the first thing is the homologous series. So alcohol is a homologous series, a family of organic compounds that share the same chemical properties. That's the definition of a homologous series. And members of the same homologous series contain the same functional group. And functional group is an atom or group of atoms shared by all members in the homologous series, and it gives the chemical properties to the compound. That's the functional group. So for alcohol, the functional group is the OH, is the hydroxyl group. And bear in mind that OH is a single bond. So over here would be all the carbon, for example. So this is one example of the alcohol of a member of the alcohol homologous series. And this compound is called ethanol, C2H5OH. OH is the functional group. And the general formula of the alcohol homologous series is CnH2n plus 1 OH. Okay, take note for alkene is alkane CnH2n plus 2, and the N basically starts from 1, 2, etc. And then for this is alkane homologous series. For alkene, that will be CnH2n, and the N doesn't start from 1, the N start from 2, because you need minimally 2 carbon atoms in order to have the carbon-carbon double bond. Alkene has carbon-carbon double bond. And for alcohol, that would be the general formula would be CnH2n plus 1 OH, and the N start from 1. Okay, so these are the first four members of the alcohol homologous series: methanol, ethanol, propanol, and butanol. And you need to know how to draw the structural formula. You cannot just stare at it, you got to practice drawing it. And the physical properties of alcohol, boiling and melting point. So it has low melting point. It is volatile, liquid. Volatile means low boiling point, and it is soluble in water, obviously. Like for example, ethanol is soluble in water. In fact, all of them are soluble in water. So you can see that the boiling point increases going down the group, going down the homologous series. So this is actually the trend. Yeah, so the trend of alcohol is going down the alcohol homologous series. Molecular size increases, intermolecular attraction forces increases. So large amount of energy is needed to overcome the forces, and because of that, the boiling point increases. So this trend is similar, or is exactly the same as alkane and alkene. So you can see that the solubility actually decreases going down the group. Okay, let's look at the chemical properties. Chemical properties, same as alkane and alkene. The first chemical property of the first chemical reaction is combustion. So same things, similar to alkane and alkene. The two products of combustion are carbon dioxide and water vapor. The difference between the combustion of alcohol and combustion of alkane and alkene is that for combustion of alcohol, it causes less pollution, so no soot is produced. Yeah, soot is basically the unburned hydrocarbon. Okay, the second chemical property of alcohol is oxidation. So when you oxidize alcohol, you will get ethanoic acid, you get carboxylic acid, and water. So this ethanoic acid is actually a carboxylic acid, which is the next homologous series after alcohol. And one application of oxidation of alcohol is the use of breathalyzer, where the traffic police use it to catch drink drivers. Okay, so this breathalyzer, inside there is an oxidizing agent, and then when the driver drinks alcohol, there will be alcohol present in his or her breath, and then this alcohol will be oxidized by the oxidizing agent in the breathalyzer, and it would produce carboxylic acid, which will be detected and then shown as a reading on the breathalyzer device. So in the lab, in order to simulate the oxidation of alcohol, usually we use an oxidizing agent. Of course, we can use oxygen in the air, but then the oxidation would be slow. So by using acidified potassium manganate 7, which is the oxidizing agent, then the ethanol would be oxidized much faster. Yeah. Okay, now we look at the manufacture, or how to make ethanol, how to make alcohol. So first is the addition of steam to ethene. Using steam to react with alkene, alcohol, in this case ethanol, is produced. But in order to do that, we need phosphoric acid H3PO4 as the catalyst, 300 degrees Celsius and 60 atmospheric pressure. Okay, this is the chemical equation. The second method is the fermentation of glucose. So this method is used to make ethanol. So fermentation, this is the definition: a process where microorganisms such as yeast use enzymes to break down glucose in the absence of oxygen. So it must be absence of oxygen. That is why this flask which contain glucose solution and yeast need to be sealed, yeah, so that the amount of oxygen inside will decrease over time, and then when there is no oxygen, the yeast will break down the glucose molecule to produce ethanol and carbon dioxide. Okay, so this chemical equation is very important. Must know how to write this chemical equation, very important. So this is what happened in the lab. We can simulate the fermentation, glucose solution and yeast. And then the carbon dioxide will be bubbled into the lime water. So over time, white precipitate is formed in the lime water. So the required condition is not at room temperature fermentation. Fermentation of glucose doesn't happen at room temperature. So it needs to be 37 degrees Celsius. Higher temperature, the yeast will die. Okay, and then no oxygen. So the flask here need to be sealed, as I mentioned just now. Rubber band is secured airtight to flask. One end of the delivery tube is immersed into the lime water to prevent oxygen from entering the flask, and also to for us to note that the carbon dioxide is produced later. So there are two purposes of this delivery tube being immersed into the lime water. One is to prevent oxygen from entering through the delivery tube to the flask, and the other reason is really for us to know that carbon dioxide is produced, then so that we know that fermentation is occurring. Okay, as fermentation occurs, the concentration of ethanol in the flask will increase, and this concentration of ethanol cannot exceed 15%. So if the ethanol in the solution, in the glucose solution here, exceeds 15%, what will happen is that the fermentation will stop, and because the yeast will be killed by the high concentration of ethanol. Yeah, so the solution here, so before the concentration of ethanol reaches 15%, it needs to be separated from the sugar solution and yeast. The ethanol need to be separated through fractional distillation. Otherwise, the yeast will be killed and the fermentation will stop altogether. Okay, in the presence of air, oxygen oxidizes ethanol to produce carboxylic acid. All right, so the ethanol can be oxidized by oxygen to form carboxylic acid and water. Okay, some uses of ethanol. Ethanol can be obviously can be used as alcoholic drinks, can be used as a solvent, because alcohol can dissolve many substances that are not soluble in water. Yeah, so when the chemical is not soluble in water, then we have to use other solvent, and very commonly alcohol is used, or ethanol is used as a solvent to dissolve that particular chemical. And as a fuel, ethanol is a very clean fuel. Okay, the next homologous series would be the carboxylic acid. So carboxylic acid, the functional group is COOH. And take note, there is an OH, and OH, as you know, is the functional group for alcohol. But this is carboxylic acid, and this COOH is called the carboxyl group. And take note, it is C double bond O, C single bond O, H. Okay, C double bond O, C single bond O. Just now for the alcohol, there is only single bond, there is no double bond. For alcohol homologous series, for carboxylic acid homologous series, there is a C double bond O, C double bond O here. Okay, so similarly, we need to know the first four carboxylic acids compound. So these are the methanoic acid, methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. All right, the general formula CnH2n, instead of CnH2n plus 1 OH, this one is CnH2n COOH. And take note, the N start from 0. Okay, so for carboxylic acid, it is CnH2n plus 1 COOH, and the N doesn't start from 1, doesn't start from 2, it starts from 0. Now, why does it start from 0? Because when it starts from 0, all this is 0, right? So this one, so this C0 is gone, it's 1. And H, when N is 0, H will be 1. And then COOH. So there is an additional C here. That is why when N equal to 0, the carboxylic acid is actually like this. This is the carboxylic acid when N equal to 0. And this guy here is called methanoic acid. Methanoic acid. So the first member of the carboxylic acid homologous series is methanoic acid, HCOOH. Of course, the molecular formula, you can write it, you can combine all the O and the H to become CH2O2. All right, so first member of the first member of the carboxylic acid homologous series is when N equal to 0, and it is called methanoic acid. So there is still one carbon atom. That's why it's called meth. One carbon is meth, right? Okay, similarly, we look at the physical properties. So soluble in water or carboxylic acid, methanoic acid, ethanoic acid. By the way, ethanoic acid is the acid in the vinegar. Do you like vinegar? I like it. Yeah, vinegar is basically to improve the taste of certain food. Okay, ethanoic acid, propanoic acid, butanoic acid. And the trends exactly the same as alkane, alkene, and alcohol. So as you go down the homologous series, molecular size increases, intermolecular attraction forces increases, large amount of energy is needed to overcome the forces, and because of that, boiling point increases. Let's look at the chemical properties. So as the name implies, carboxylic acid is an acid, And the difference between carboxylic acid and normal acids like hydrochloric acid, sulfuric acid, and nitric acid, the difference between them is carboxylic acid is a weak acid. What do you mean by weak acid? So recall chapter 8, acid and bases. All acids has hydrogen ions. And weak acid, basically it would, the acid molecule would dissociate or ionize partially in water to form a low concentration, of H plus ion. Okay, please add in this one, low concentration of hydrogen ion. So that is why carboxylic acid is a weak acid, because it contains low concentration of hydrogen ion. Unlike HCl, H2SO4, HNO3, all of them are strong acid, so they ionize fully in water to form high concentration of hydrogen ion. Okay, so this symbol here means ionize partially. It means only some of the molecules, only some of the carboxylic acid molecules would dissociate or will ionize to form hydrogen ion. So most of them remain as molecules, some dissociate. Okay, so the chemical properties of carboxylic acid is just the same as the chemical properties of metals. Okay, so first of all, we have reaction between acid and metals to form salt and hydrogen. So no reaction between carboxylic acid and unreactive metals such as copper, silver, and gold. Au is gold. And then the reaction between carboxylic acid and bases, just like acid and base, salt and water. You have a salt and then you have a water as the product. And of course, you have a reaction between acid and carbonate, or carboxylic acid and carbonate, to form salt, water, and carbon dioxide. Yeah, so this is actually in the pure chemistry syllabus. Carboxylic acid and alcohol to form ester and water. Okay, how to prepare carboxylic acid? You can oxidize alcohol. Okay, oxidized alcohol is either by oxygen in the air, atmospheric oxygen, or oxidizing agent like acidified potassium manganate. So there is a acidified in front here, acidified potassium manganate 7. Yeah, so the acidified potassium manganate 7 would turn from purple to colorless. And when it is oxidized, when ethanol is oxidized by atmospheric oxygen, it will be much slower. The carboxylic acid will form much slower compared to this. So this is fast, this is slow. Alright, that's the end of alcohol and carboxylic acid chapter. Thank you for watching. See you next time. Bye bye.